Now we were going to speak about angular velocity. As I already told you that in this case the velocity will not be just a time derivative of this r. So r is something that gives us orientation, but if we'll take a time derivative of that, it will not be angular velocity. So r dot is not an angular velocity. So let's assume that we have a body. A body with a frame, let's call it frame A. And we want to go to another position, another orientation. We want to have something like this. And it will be another frame CB. And right here we have a point P. What can we write? We can write that PA equal to RAB times, what should I write? PB. It's like we have two frames, A and B. P is the position of this point in frame A. It is this position of the same point, but in frame B. And we can go from one frame into another one. It's just a matter of representation. P is just physical point. A and B denotes us that it's not a physical point, but a bunch of numbers already, because we express it in the frame A or B. All right? We can write the same for the B, and it will be RBA, PA. Let's take a time derivative of that. Let's assume that we want to express velocity of that. Let's take a time derivative. It will be the derivative of a product. So it will be R dot AB PB plus RAB PB with a dot. What do you think about that? What it will be? When, you know? Zero, because we consider that it is a rigid body. The distance between them does not change. So it is a constant. The product of the derivative of a constant will be 0. All right. Instead of PB, I can write this thing, and it will be R dot AB R AB BA times PA, or in other words, I can rewrite it as R dot R inverse or R transpose PA. So what can we see here, that P dot equal to R dot R transpose PA. And it happens that it's nothing else than the angular velocity. So angular velocity here, it's Q representation, correct, I will denote it with the tilde, because it is 3 by 3 matrix, 3 by 3. The product of them will be also the 3 by 3. And if we'll do the multiplication, you will get the skew-symmetric form, and it will be the angular velocity. So the angular velocity now, not just r dot, but r dot times r inverse. So if I'll go back here, I can actually, let me rewrite it. So the angular velocity so here it will be a little bit different from the notation of Kevin Lynch. I'm going to use 3 indices instead of 2. And I will do the following. So angular velocity of a body with a frame B that moves around another body with a frame A, and the motion expressed in the frame A. So I'm going to use 3 numbers. So let me, I will repeat. So B, it is the frame of a body that moves. A, it's another frame around. This body moves around this frame. So the body, let me continue. A body with psi, so psi, it's like a way to express a frame. Psi b moves around psi a, and right here, this is the reference. So we express this motion in this frame. So the motion is expressed in this frame. And it will equal to the following. R times R. First of all, I need to take a look at this symbol, and I put it on the diagonal. Then I need to use a second symbol right here, and I'm going to use put a dot symbol right here. So when I have the same indices for the superscript and underscript, it's like I can express the same motion of the same body B that moves also around A. So here it's not really correct, will be. So it's like B, no, it is a correct one. So B, it is the frame which is fixed with the body. And A is initial fixed frame which is fixed with the world. So B rotates around A, and right here it was also expressed in the A, in the stationary frame, but also I can express it in the same B frame. So here I can put a B. What should I write right here? This symbol, B. What should I write here? A. It's like another symbol. And where should I put a dot?
On the second.
Right here, because we have BA, BA. And look, here it was R dot times inverse O transpose. And here it is R inverse times R. So remember I said that it's not commutative because the result will be different. And it's like the representation of angular velocity in space frame or body frame. Or actually, what can I use? I can use here another frame like C. And it will be like angular velocity of body B that moves around A, and the motion is represented in some C frame, another one. All right. Is it clear?
How would this representation we use C frame?
I will show you later. I need more structures to express it. So now we can see that angular velocity is not like r dot, but r dot times inverse or opposite way around. Now let us back to this concept of manifold. So let's assume that this is something like a curvature, just like a sphere, but 6-dimensional sphere, or even 16-dimensional. Right here it will be 9, dimension. It's 3 by 3, so the dimension is 9.
Can we say 9 parametric instead of 9 dimensional?
Yeah, yes, you can. It's like it will be the same.
We've now in the string theory, we have 9 dimensions.
All right. The point here is that actually I cannot draw this curvature, but we can think about it. We have here something which is called identity. So as you remember, a point on this curvature indicates as the configuration of our robot, for example. And identity, it's like an initial point. For example, we can think about our robot, which is in the candle position when all the angles equal to the 0, for example. And if we change the position of joints, it means that we will change the configuration, and the point of representation we will travel along this curvature. So it will be our representation of our orientation. Since this curvature is differentiable, we can take the time derivative, this thing, and we can create a vector space. So the vector space, it is a plane which is tangential to the surface. It's like, let's go back to the example with the Earth. If you travel, you do not use a globe because it's not very convenient. You use atlas. It's like maps. Maps are printed on the plane, and it's like if you're traveling in St. Petersburg, you need a card with a map with St. Petersburg. But if you go to Moscow, you need another page with another representation. It's like if you have a plane, in each point, we can take a plane which is tangential, right? The same story here. And it will be a vector space. And in this vector space, it will be a place to live for r dot. And if we multiply r with r dot, you will have a result that will live right here, another vector space, but in identity point, and it will be the angular velocity. And it's called the Lie algebra. It's called SO3, but not in capital letters, but with the small letters. So here I just wrote you that ABC, angular velocity of A in respect of B expressed in C. So the result is called Lie algebra, and it is denoted with the small so. It also has a special property, the property to be skew symmetric, right? So here it's several words about manifolds. So here the same drawing that I just have draw. Identity point, tangent space, manifold, m dot. So the same that I just draw here. All right.